Welcome to Silicon Scoop, where we dive into the latest tech news impacting the world. Join John Irwin and the Startup Coach as they explore the tech news that matters to you. Stay ahead, stay informed, and now on with the show.
Everything we knew about how metals conduct electricity just got turned on its head. Textbooks said you couldn't manipulate charges inside a metal like an insulator, but scientists just found an atomic control knob that changes everything for the future of chips. Get an atomic dial now, as researchers have successfully stabilized electrical polarization inside a metal, stacking ultra-thin layers just nanometers thick. By doing this, they can radically alter how the metal conducts and communicates at an atomic level without changing the material itself. This effectively allows engineers to custom tune computer chips components by thickness alone, bypassing the messy, expensive chemical modification used today. What do you think about this, John?
This kind of blows me away, and let's just dive into like the core discovery here. So, like you said, the breakthrough centers on a phenomenon called interfacial polarization. And so let's talk about that for a second. Normally, polarization effects are associated with insulators and ferroelectric materials. It's substances where electric charges can separate internally. So metals typically screen out these electric fields almost instantly because electrons move freely inside them. So what shocked researchers is that they were managed to stabilize polarization effects inside a metallic system. Specifically, they demonstrated that atomic scale engineering at the interface between materials could substantially modify the electronic surface properties of metallic ruthenium dioxide. So the researchers, they tuned the material by changing film thickness at the nanometer scale. And once the ruthenium dioxide layer became ultra thin, I think it was around 4 nanometers, the interface effects began dominating the metal's behavior. So why this works? So the study focused heavily on changing the material's surface work function, which is one of the most important properties in electronics and catalysts. So the work function represents the minimum energy needed to remove an electron from the material's surface, a key parameter in controlling electron transport. So the behavior of semiconductor junctions affected catalytic activity and battery and fuel cell efficiency. And the researchers, they reportedly achieved shifts greater than 1 EV, electron volt, not EV, electric vehicle, little e, capital V. So in material science, that's enormous, okay? Even small fractions of an little e, capital V, EV, can drastically alter how electrons flow through a device. So what this means is that engineers may someday tune materials dynamically for lower resistance or faster switching or better catalytic reactions or even more efficient charge transport, all without changing the chemical composition of the material itself. This is kind of cool. It's hard to wrap my head around this as far as like the full science of it, but from what I understand and what I've understood from the reading and the research, this is really cool. What are your thoughts behind this, Craig? Or do you want to explain it in more layman's terms?
Well, I will, but I like the key to this is on the fly. You know, it's not like we build this for one use case scenario. It's actually built for all of them. We change on the fly. For example, think of this update like upgrading your car's tires. Normally, if you want to switch from driving on a smooth highway to off-road in the mud, you pull over and completely change the tires to a different material. What these scientists did is create a magic tire that changes its entire grip and tread pattern completely on its own, simply by adjusting how inflated it is by a literal hair's width. Oh, you get a totally different performance without ever swapping out a part on the fly in real time.
Yeah. So historically, metals engineering, it relied on 3 things essentially: changing chemical composition, alloying metals, and doping semiconductors. But modern material science, what's happening is it's increasingly moving forward with interface engineering, quantum confinement, and atomic scale architecture. So the material itself matters less than how atoms are arranged, how layers interact, and how electrons behave collectively. So this is kind of similar. Like, think about what's happening here to how the semiconductor revolution evolved from simple silicon chemistry into this nanoscale transistor engineering. But that's where we're at right now.
Absolutely. I mean, this is going to change the game. Like, this was just done in the lab a couple of months ago in February. So it should hit commercial chip pipelines within the next few years. But because it removes the need for expensive chemical additives, the dopants in manufacturing, it drastically lowers the production cost of, or it could, of next gen tech. So we'll have to see if, this is going to reduce those costs, and it deeply impacts the foundational hardware of advanced CMOS microchips, quantum computing sensors, and clean energy hydrogen fuel catalysts. So while we won't see it tomorrow, the design principle, the exact kind of physics breakthrough required to build a hyper-efficient ice-cold processors needed to run the next generation AI hardware without melting out our power grid. So this is really cool.
Yeah, essentially the breakthrough is that they found a way to control metals without changing the metal itself. That's, to put it simply, right? I'm excited to where this goes and how this will help, especially with AI hardware. That's going to be interesting to see where that fits in.
Yeah, this is the most fundamental conceptual shift in electronic material manipulation since the implementation of chemical doping in early silicon transistors. Instead of altering a material's behavior by contaminating it with impurities, we are altering it purely through spatial geometry and physical strain. So the imaging technique used to prove this, the electron phytography, doesn't just have a picture. It uses advanced algorithms to reconstruct phase of electron waves, allowing scientists to measure atomic shifts smaller than the wavelength of the electrons themselves. The U.S. Air Force Office of Science and Research co-funded this because reconfigurable metallic surfaces are the holy grail for stealth tech, next generation radar, and radiation hardening defense hardware. And the critical transition point of this world-changing electrical shift happens at 4 nanometers, which is exactly the same width as the single strand of human DNA. So while this fabrication method, the hybrid molecule beam epitaxy, is technically wafer compatible, atomic layer accuracy across a massive commercial foundry production line is notoriously brutal to maintain without defects throwing off target thickness. So we'll have to keep seeing how long this takes to go from the lab to full production. What do you think, John? I'm
excited for this. So, like, if I can just put it simply, the scientists have just found a way to control electrons without magnets. This is what they've done. I'm super excited for this. Again, this talks to more quantum kind of stuff, but that's where we're going with all these new quantum discoveries. We're essentially discovering a whole new world of physics.
Yeah, metals are no longer just dumb static wires in a circuit. They're officially a dynamic, tunable design element. Do you think breakthroughs like this will save silicon computing, or are we inevitably going to ditch the silicon entirely for true quantum hardware? Let us know what your thoughts in the chat.
Tired of drowning in repetitive tasks while your competitors race ahead? Every minute you spend on manual data entry, scheduling, and routine processes is a minute you're not growing your business. Flowgrammer.ca transforms your workflow chaos into seamless automation. We build AI-powered systems that handle your busy work so you can focus on what actually makes you money. Our clients typically save 15 plus hours per week and see their productivity double within 60 days. Visit flowgrammer.ca for a free automation audit. That's flowgrammer.ca. Stop working in your business and start working on it.
What do you got going on, John?
Just plugging away, helping companies with government funding, attending events, probably startup drinks or Flowgrammer events. How about you, Craig?
Lots of stuff going on. I honestly don't know when this is going out. I have to check. I think it's going to go out in April. But there's all sorts of stuff going on. If you don't know about OpenClaw, it's the latest AI automation agent that's taken the world by storm in 2026. And OpenClaw Toronto chapter just launched, and we have all sorts of events going on. So check out openclawto.com. Our first demo night is April 14th. We have a Builder Cafe on April 10th. We have a bunch of other events. There's updates every day. We've deconstructed the latest 2 betas over the weekend that was launched in OpenClaw and what you should do about them. There's a bunch of articles over there. Go check that out. We're also over at flowgrammer.ca, where we do N8N automations. We run the Flowgrammer community and do Builders Hub and connectivity for AI and business automation agents. And for everything else, head over to TorontoStarts, where we hook up startups and investors at our Startup Investor Drinks. We do mentoring, we do workshops, we have a list of investors. There's a whole bunch of content over. You can also book me over there if you want a meeting with me to talk about whatever, help your startup. Check out TorontoStarts.com. But John, if people are looking for non-dilutive funding, where should they go and what is that?
Yeah, non-dilutive funding. We're talking government grants, tax credits. Come find me on LinkedIn if you have any questions. Right now is Shred Time, SRNED. But come reach out to me too. If you've got a startup, if you've got a company, reach out to me if you have any questions. And if they have company questions about their startup in general, where do they find you, Craig?
Yeah, find me at TorontoStarts.com. But John, just before we go, something's open right now, and it's closing May 31st. Thank you. Can Export. And what?
Yeah. So
what
if
should
you have
people
at
know
least
about that?
300,000 in revenue in the previous year, and you're looking to expand outside of Canada, reach out to me, and we can put together. We can talk about an application for Can Export.
All the links we talked about will be in the show notes wherever you're watching this. Thanks for watching, everybody. Leave us a comment, give us a like, give us a subscribe. We really appreciate it. Thanks, everyone.
Thanks, everyone.
Thanks for tuning in to Silicon Scoop. We hope you enjoyed this episode's dive into the latest tech news. Stay connected with John Irwin and the Startup Coach on LinkedIn and subscribe for more insights and updates. Until next time, stay ahead, stay informed.